All right, so I think this is recording. Let's take a look here at number 9. Our parent function is the log function. It's a common logarithm. The base 10 is implied. Our first transformation is reflecting it across the y-axis. That's going to be a transformation on x. And then the next three transformations to reflect it across the x-axis, to vertically stretch it, and to shift it up, all of those are affecting the y-coordinate. So the equation that they want is the reflection across the y-axis takes the opposite of x. So we take the log of the opposite of x, and then that gives us the output of the function. And now we're going to start doing things on the outside after we've applied this function to affect the y-coordinate. So to reflect it, we'll need a negative sign, and to stretch it, we'll have to multiply it by 4, and then to lift it up 5 units, we'll have to add 5. So this is our final answer, and you can check this final answer by using that Desmos graphing calculator. You don't have to, but I think that's cool to see the actual transformations. So here's the graph of our log function. So there's the parent function. You can see in shape how close it looks to the square root function, but the square root function actually starts at the origin, where this guy just gets closer and closer to the x-axis, but it never touches it. As you zoom in closer and closer and closer, you see that gets close to the y-axis, but it just never touches it. And if I look at the square root of x, see how it starts at the origin, but see how it goes to the right. It's clearly above it, but when you get out here, look, this square root is steeper than the logarithm, but it has that shape. Anyway, let's go back. I guess that has nothing to do with this. Just my comment. Sorry about that. Our first transformation is to reflect it across the y-axis. So we take the log of negative x, and then our second transformation, and I'm not doing this in function notation because I don't have another problem that has the same transformations for this parent function, so I'll just key it in using rather than using the function notation. So if I reflect this across the x-axis, that's a negative on the outside. And then if I do a vertical stretch by a factor of 4, and then I don't know what I did there. Oh, I lost my equal sign. And then the fourth transformation is to push it up. All right, so let's see how we get to our final answer. So there's our parent function, which is the log function. This first transformation reflects it across the x-axis. Then we work with that function, and we reflect it across. Did I say what? We started here with the y-axis, and we reflected it. Now we reflect it across the x-axis, and now we vertically stretch it. So this point, let's see if we can find, here's where it's close to negative 1, and that's going to get multiplied by 4 and become a negative 4. So this point that was here at at negative 10, negative 1 is down here at negative 10, negative 4. So it was a vertical stretch. And then this is going to lift it up 5 units. So this that was at negative 4 is going to go up to 1. It's going to go up there. And there it is, up at 1. This negative 10 is up at 1. So we started with this parent function of the log function, and we ended up with, well, let's zoom out, with this function that is transformations on this log function. So pretty confident that our answer is right. So I will talk to you later. Bye.